Hello everyone, welcome back to another section of online chemistry classes. So in the last class we were discussing about ammonia from the chapter study of compounds. So in the last class I have asked you to refer some of the experiments from the previous part, that is from HCl. I asked you to refer the red fountain experiment from HCl. So today I hope you all have referred that. Today we will be continuing with our ammonia chapter. So in the ammonia chapter, as I have told before, just like red fountain experiment, there is one similar experiment, that is blue fountain experiment. So today at first we are going to discuss the blue fountain experiment. So we have completed the laboratory preparation and as well as industrial manufacture for ammonia. So according to the step, first we are supposed to complete the laboratory preparation, then industrial preparation, the next one it is supposed to be chemical and physical properties. So before going to the chemical and physical properties, I am going to discuss this blue fountain experiment. In the last class, or in the not in the last class, in the last part when I was teaching the red fountain experiment, we discussed the red fountain experiment and we arrived at certain conclusion. So here we will directly do the experiment. We will observe what is happening and we will guess what are the physical and chemical properties of ammonia that can be explained from the blue fountain experiment. Okay, now as you can see, we have set up a blue fountain experiment for ammonia. Inside the RB, it is filled with ammonia gas. In the last experiment, that was a red fountain experiment, instead of this ammonia, it was HCl gas. Now it is instead of HCl gas, we are adding ammonia gas. Okay, so there is not much change other than the ammonia gas filled instead of HCl gas, and the last change that is going to happen, it is in the vessel that is kept below. In the previous case we used to fill blue litmus solution here. Now for blue fountain experiment we are supposed to fill the red litmus solution. Okay, so there are only two changes in the diagram compared to the red fountain experiment as well as the blue fountain experiment. One is a gas film. So in the red fountain experiment it will be HCl, in the blue fountain experiment it will be ammonia. Now the next change is red litmus solution for blue fountain experiment, blue litmus solution for red fountain experiment. Okay, I hope you remember this. Now, what I did after arranging all the setup, the next procedure for the experiment is to press the bottom of the dropper. So this dropper, it is filled with water. When it is pressed, what happened? All the water that is inside the dropper, it is supposed to be coming out as droplets inside the RP flask. So in the last case, while I was doing the experiment with HCl, due to high solubility of HCl in water, what happened? All the HCl got dissolved in water. There was a creation of low pressure inside the RP. Because of that, there is a suction force, or due to the low pressure, the water from the vessel that is kept below, it was sucked up, or it started to move upwards through the glass rod, and after some time you can see a fountain like creation from the tip of the glass tube. So in the red fountain experiment, the color of the fountain was red. So what happened here is just like the same. When we are pressing the dropper, water came into the RB flask. Soon after that, there is a suction of water, and the water, it dries up and it starts to flow down as a fountain. But there was only one change in observation, that is this. Instead of red color fountain from the red litmus it was blue litmus solution or blue fountain that is observed. Okay, from the top of the glass door. Now we are supposed to conclude our observation. There is two observations. One is the color change. The red litmus solution, it turned into blue when it is coming to the top. So this is blue. Okay, so the red litmus, it is turning to blue fountain from the top of the glass rod. That is our first observation. The second observation, that is the water from the vessel, it is being sucked up, or the water from the vessel it dries up to the glass rod, tip of the glass rod, and it is falling down as a fountain. So similar to the previous conclusion in the red fountain experiment, we are supposed to explain the properties of ammonia based on these two observations. Okay, so first let us observe. First, let's conclude based on the color change. The color change here was from red to blue. Okay, so in the previous one, it was from blue to red. So the conclusion for that color change was a compound which can convert blue litmus to red. It is called an acid. So here it is just opposite. It is converting red litmus solution to the blue. So a compound that can convert red litmus to blue, it will be called a base. So that means NH3 is a base. So the first conclusion that we are arriving from the blue fountain experiment, it is this. There is a change in color of the litmus solution. It is changing from red to blue. So it is due to the presence of ammonia gas in the RD flask. So from this we can identify that the ammonia gas, it is basic in nature. Okay, so that is our first conclusion in this experiment. And there is one more. There is a low pressure reaction that is inside the RD flask, which was much similar to the case of HCl gas when we are doing the red fountain experiment. If something similar is happening when we are filling ammonia gas inside the RD flask, that means ammonia and HCl, it is having one property similar. Okay, so that means it is not acidic or basic property. Other than that, there is one property that is similar for ammonia and HCl, that is this NH3 for ammonia is highly soluble in water. Okay, so as you remember in the chapter HCl, we have discussed this property of HCl, the high solubility of hydrogen chloride gas. Similarly, ammonia is also a gas which is highly soluble in water. Okay, so now we have discussed one chemical property and as well as one physical property of ammonia. Okay, the chemical property that we discussed was the basic nature of ammonia. The physical property that we discussed was the high solubility of ammonia in water. So we'll go through the other physical and chemical properties of ammonia. First we'll go through some of the important physical properties. So the first one is color of ammonia gas. Ammonia is a colorless gas. Odor or the smell of ammonia, it is irritating, pungent smell. So pungent choking smell, strong pungent choking smell. So pungent means it is something similar to irritating smell. The pungent is the exact word. You are supposed to write it as such. HCl is also having the same smell. Okay. Now taste. So in the last class, in the last part, that is hydrochloric acid, when we are discussing about hydrochloric acid, while discussing the property of hydrochloric acid, I have told this, all the acid they are having sour taste. So all the fruits, the that they contain little bit amount of acid in that. For example, lemon, they are called lemon, and orange, they are called citrus fruit because they contain citric acid. Because of the presence of citric acid, they are having little bit of sour taste. Now, what about the bases? So all the bases, they are having bitter taste. So an example is bitter gourd, so it must be having, because it is having bitter taste, that means it must be having little bit of base in the bitter gourd. Okay. Now, other than that, other than the taste, it is, this gas is actually not a poisonous gas, but still, if you are inhaling too much, it is not good for your body. Then high solubility or in water. Okay, that is the important property of ammonia, and it is one of the easily liquefiable gas. So it was actually used in used as a refrigerator in the previous cases, that will be around 90s or 80s. I don't remember, but now we are not using because we are having better refrigerants compared to ammonia. So we are not using that. Now, that's all about the blue fountain experiment. You can compare the red fountain experiment and blue fountain experiment and study it together. Don't confuse between both. Don't get confused between both. Okay. So now we'll be moving to the other chemical properties of ammonia. The first chemical property we have already discussed, that is the basic property of ammonia. We will be discussing more about that later. So the next one, it is the thermal dissociation. Okay. Okay. For the thermal dissociation of ammonia, I hope you remember the reaction for the Haber process of ammonia. It was something likewise, N2 plus 3H2 reversibly gives 2NH3. I am not writing the conditions now. So we are going to discuss about what happened to ammonia when we heat ammonia. Okay, so I think I have discussed this in the last class. So forward reaction or the production of ammonia, it is exothermic in nature. So if we are decreasing the temperature, it favors the production of ammonia. If we are increasing the temperature, it favors the production, it favors the decomposition of ammonia to N2 and H2. Okay, so if we are heating ammonia, in other words, if we increase the temperature of the container that contains ammonia gas, the ammonia gas, it will split into its component gases, that is N2 plus 3H2 by absorbing heat energy. Okay, this is the thermal decomposition of ammonia. It can happen at higher temperature, above some 600, 700 degrees Celsius. It is better, it will decompose faster at higher temperature. So this is the thermal decomposition of ammonia. Next one that we are going to discuss, it is the basic property of ammonia. So what is a base? A base is a substance that can produce OH minus when dissolved, OH minus ions when dissolved in water. There are many other definitions for a base. It is a compound that can it is a compound that can abstract H plus ions or protons from water. There are many definitions, so we will go with any of that. So ammonia is a base according to a concept called Lewis concept, or in other words, ammonia is normally called as a Lewis base. So I hope you remember other bases. Okay, NaOH, CaOH twice, MgOH twice. These all are some alkali as well as bases. CaO. Okay, so what is the difference between all that bases and ammonia? I hope you remember that all these bases, they are having at least one oxygen in that. Ammonia is not having any oxygen in it. It is just having 3 hydrogen. Okay. So why ammonia is considered as a base? So I hope you remember from your second chapter the structure of ammonia. It is having 3 hydrogen, which is bonded by 3 covalent single bonds towards a nitrogen. Now, other than that, ammonia is having 2 electrons which doesn't take part in the bonding. They are called lone pair of electron. In other words, ammonia is having presence of 1 lone pair. Now, when ammonia is reacting with anything that can abstract a lone pair, for example, a X plus ion, what happened? I hope you have studied this reaction also. Ammonia will easily donate this lone pair to the donor type of species and it will form I hope you remember this. This in a short way we can write it as NH4 plus, or it is called the ammonium ion. Okay, so ammonia, it can donate the lone pair to H plus. In other way, ammonia can take up one H plus or it can take up one proton to form a different species. So in other words, it is something that can remove H plus ions from water, so it is considered as a base. Now we can write the same reaction in a little bit different manner. So it is this. So I hope you know what is this. This is the electron structure for water molecule. So I hope you remember the polar and non-polar compounds. Because of the polarity, ammonia and water both are polar organic compounds. Not organic, polar covalent compounds. So this lone pair, it is a pair of electron. Definitely it will be having a slight negative charge. You can consider them as negative. So here there is some partial positive charge for the hydrogens in the water. So this lone pair, it can be easily given to the one of the delta plus hydrogen in the water. So what happens here is, when this lone pair, it is moving towards the hydrogen, this bond, there are 2 electrons in this bond, these electrons will be shifted towards the oxygen atom, and the resultant product is, so earlier there was NH3 and it abstracted 1 hydrogen from the water, so it will be NH4 plus, and whatever that is remaining. So this was our water. So from the water, this hydrogen was taken away from the by the ammonia. The whatever that is left over, that will be OH minus. So NH4 plus OH minus. In other words, it is called NH4 OH 4. In other words, if ammonia, it is reacting with water, it will form ammonium hydroxide, which is also known as which is also a weak base. Okay, so because of this nature, you can definitely prove that ammonia, it can be considered as a base. Okay, so because ammonia is a base, I hope you remember the conditions of the indicators. In case of litmus solution, just now we have discussed, it can turn the red color of litmus solution to blue. So what if we are taking blue litmus solution? There won't be any change. Now I hope you remember the color change for phenolphthalein and methyl orange. So in case of phenolphthalein, I'm just writing. Okay, in case of phenolphthalein, the color change it will be from colorless. So phenolphthalein it is colorless under two conditions, under neutral condition as well as under acidic condition. So phenolphthalein it is colorless in the neutral and acidic condition. So what will be the color in ammonia? Ammonia is a base, so in the basic condition, the color it will change from colorless nothing to pink color. So there is a, if you are adding ammonia into a solution of phenolphthalein or vice versa, you can observe a color change to pink. Okay, now what about the methyl orange? Methyl orange. So in case of methyl orange, so as we have discussed before, in case of acidic condition, it was having an orange color. In the last chapter they have written it as red. In this chapter they have written it as orange. Leave it, just fix that as red only. So in case of methyl orange, the color change will be from red to yellow. Actual color change is from orange to yellow only, but in different textbook or in the same textbook itself there are many changes. So you go with the red or orange your wish. Okay. Now you will get mark for both red and orange. Now the next is the reaction of ammonia with oxygen. There are two types of reaction that we are supposed to discuss. These two are important because the second reaction that we are studying here, we'll be studying that again in the next chapter in the industrial manufacture of nitric acid. Okay, the same exact reaction, all the condition, everything is same. So it is called that reaction. It is called catalytic oxidation of ammonia. So that will be exact same in the next chapter. And the other reaction, it is not that much important, but the observation it is little bit important. You don't have to study the procedure, all that thing by heart, just go through that. But the reaction, the chemical reaction is important and the observation is important. Okay. Now we move to the next chemical property. Okay. The first reaction, the reaction that is less important compared to the next one, burning of ammonia in oxygen. Okay, so this is the reaction. Ammonia react with oxygen to form two products, O2 and H2O. So here what we are doing, we are just burning ammonia with oxygen. No use of catalyst, nothing else. We are just burning ammonia with oxygen, direct combustion. But there is a problem. This reaction is not easy. Okay, the reason is this: ammonia, it is not a combustible gas. It's not a flame extinguisher or something, but it is a gas that doesn't catch fire easily. Okay, so because of this, if you are just mixing ammonia and oxygen, if you are if you are bringing a matchstick near to that, nothing, it is not easy for it to catch fire. It need little bit higher temperature for the ammonia to catch fire. So the reaction that is written in the board, that is not an easy task. So what we are usually doing, it is likewise, we'll take a setup, we'll fill it with cotton, and through this we'll introduce two tubes. The lower end will be given through the lower tube we will supply oxygen, and to the other one we will supply ammonia. So the reason is we want the ammonia and oxygen to be mix properly. So if you are putting a level of oxygen, level of tube of oxygen, then more amount of oxygen will be able to mix along with the ammonia, which will make combustion faster. So under this condition, under this setup, if we are treating it with some flammable substance, ammonia can catch fire. So when it does catch fire, it burns with a greenish yellow flame. So after a long time, you can see a flame. That flame coloration is greenish yellow. Okay, so what is more important here, that is this observation, ammonia is a gas that burns with greenish yellow flame. Other than that, you are supposed to study the chemical reaction that is written on over here. There are two reactions of ammonia with oxygen. This is burning. Burning means it is direct reaction of ammonia with oxygen. There are two products. One is nitrogen and other is water. Okay. So and it will give the greenish yellow flame. Now the next reaction, it is little bit different. It is the reaction with ammonia and oxygen. The reactants are same, but it is not taking place. Normally it is taking place in presence of certain catalysts. I think the catalyst that we are using is platinum, and we are taking high temperature condition. Under this condition, instead of producing nitrogen and water as a byproduct, we will get something else. So the reaction is different, the products are different, reaction conditions are also different. So we will go to that next. Okay, this is the next reaction that we are supposed to discuss. This reaction or this setup, it is called catalytic oxidation of ammonia at very high temperature, that is 800 degrees Celsius. The catalyst that we are using is platinum. So at 800 degrees Celsius and platinum as the catalyst, the ammonia, it will react with oxygen to form two products. The one is water, just like the previous case, and the other product that is more important is not N2, it is NO. Okay, nitrogen monoxide. Okay, so this is the reaction that we are going to discuss in the next chapter also. This is there in the next industrial manufacture of nitric acid, which is also called Oswald process. So you will be studying this again in the Oswald process. So this is one of the important reactions that you can expect in the board paper. Now there is a problem with this. That is this NO gas that is produced in this reaction, it is very less stable. So if you are collecting that NO gas, so if the temperature at the current condition, the temperature is 800 degrees Celsius, but if you are lowering that temperature, so if the temperature is decreased to about some 50 degrees Celsius, the NO gas, it can react further with oxygen. It is highly unstable at lower temperature, so it will react further with oxygen to form another gas that is called NO. Okay, so the reaction will be 2NO plus O2 gives 2NO2. And there is a problem here. There is a different observation here. The first is water and NO, both are colorless gas. There is no observation. But here, the NO2 gas that is produced here, it is not a normal gas. It is a toxic gas, as well as it is having a color. So this NO2 gas it can be easily identified by the peculiar color, that is reddish brown. So if in any part of your experiment, if there is evolution of reddish brown gas, that means there are two possibilities. One is the presence of NO2 gas and other is bromine vapor. Okay, bromine Br2. So if there is Br2 or NO2 gas, it can give reddish brown gas. Bromine, it is not there in your syllabus. So whenever you see reddish brown gas, not reddish brown fumes or something, if you are seeing reddish brown gas, not reddish brown precipitate also, if it is reddish brown gas, it is definitely NO2 gas that is involved in that process. You don't have to study about the setup, you just need to study the reaction and also the first condition and the second condition, both the temperature and other conditions as well as the balanced chemical equation, they are compulsory for your board exam. It is regularly asked. So this is all about the reaction of ammonia with oxygen. So we will move to the next part, that is ammonia, that the reaction of ammonia as a reducing agent. Okay. There is a little bit extra in your textbook that is not required for your syllabus. Just even though it is not required for your syllabus, just go through that. It will be useful for you in the future. So we will be continuing with the reduction using ammonia or ammonia as reducing agent. So I hope you remember what is oxidizing and reducing agent as well as what is oxidation and reduction. You have studied in your last year. Okay, so I hope you at least remember the oxidation and reduction as oxidation, addition of oxygen, reduction, addition of hydrogen, or in other words you can tell it with oxygen itself, it will be like addition of oxygen, it is called oxidation, removal of oxygen, it is called reduction. Similarly, addition of hydrogen, it is called reduction, removal of hydrogen, it is called oxidation. Now if you are going a little bit further, oxidizing agent and reducing agent. What is oxidizing agent and reducing agent? The substance that undergo oxidation, it is called reducing agent. Okay, so that is because of this. Because the substance is undergoing oxidation, it helps the other substance to undergo reduction, so it is called reducing agent. So the one that is undergoing oxidation, it helps to reduce other substance. So the one that is undergoing oxidation, it is called reducing agent. Similarly, the one that is undergoing reduction, it helps to oxidize the corresponding compound that is along with it. So the one that is undergoing reduction, it is called the oxidizing agent. So I hope you remember this much from the 9th class. This much part you have studied in the previous year, so that is important. For this part, we are going to discuss only little bit about oxidation and reduction. We will discuss more about that when we come back to your regular classes. So here, if you are looking at ammonia, NH3, so nitrogen, and it is having 3 hydrogen. It is having vast number of hydrogen. So ammonia can be used as a source of hydrogen, or in other words, it can be used as a good reducing agent because ammonia can help in oxidation. So here what we are going to do, we are going to remove the hydrogen from ammonia. So removal of hydrogen, that means ammonia will undergo oxidation. So the other compound that is along with the ammonia, it will undergo reduction. So because of this reason, you can tell that ammonia is a reducing agent. So ammonia here, it will undergo oxidation. The compound that we are adding along with ammonia, it is supposed to undergo reduction. So ammonia is a reducing agent here. Okay, so here we are treating, there is only one reaction that is under reduction of metal oxide. So that is this ammonia, it will react with copper oxide. Okay, so the color of copper oxide, it is black in color. So when ammonia is treated with black copper oxide, so what happened here? There is oxygen there is hydrogen here. So removal of hydrogen, it means oxidation. So just as I told before, since ammonia is acting as a reducing agent, it is supposed to undergo oxidation. So ammonia, it must lose the hydrogen. So from the NS3, if you remove all the hydrogen, what we are supposed to get? The nitrogen. Okay. So ammonia is going to lose the hydrogen. So losing of hydrogen, it is called oxygen. It is called oxidation. So ammonia will undergo oxidation and form N2 and H2O. Now, what will happen to CuO? So we have studied about redox reaction. So it is likewise. If there is oxidation reaction that is going to take place, there must be a reduction reaction that accompanies that. Okay, so always oxidation will accompany a reduction. Together they are called redox reaction. So if ammonia is undergoing oxidation reaction, copper oxide, that the black copper oxide that we have added to ammonia, this is supposed to undergo reduction. Okay, so copper oxide, it is having copper and oxygen. So what is reduction? Reduction can be explained in such a manner. Reduction, it is removal of oxygen or addition of hydrogen. So you can tell that if you are able to remove the oxygen from copper oxide, it will undergo reduction. So we are removing that oxygen from copper oxide and the product is copper. So if you remove the oxygen from the copper oxide, you will get the copper metal. So if you remember the oxidation state method, you can just write it likewise. Copper, here it is -3, 3 plus 1, plus 2, minus 2, 0. So if you are analyzing all together, the nitrogen, it is having an increase in oxidation state, so it is under ammonia, it is undergoing oxidation. Copper +2 to 0, it is having decrease in oxidation state, so it is undergoing reduction. So if you haven't studied the oxidation state method, that is also fine. You don't have to worry about that. You just need the simple method like addition of oxygen and removal of oxygen. You can explain based on that also. Now, about this reaction, so we are adding black copper oxide to ammonia to get these compounds. So the black color of copper oxide, it will be changed into some other color after the reaction. So the product here, the most important product here, that is copper. So copper, it will be having reddish brown. It will be having reddish brown color. Now it can be called as metallic reddish brown. Okay, reddish brown is enough. So there will be change from black to reddish brown. The observation is black color of copper oxide, it will be turning into reddish brown. Okay, so other part of this experiment, it is not relevant. The production of N2 and the production of water to explain that ammonia containing nitrogen and hydrogen, it is not relevant for your syllabus, so you can leave that. So we will be moving to the last part of this chapter, that will be reduction of chlorine to hydrogen chloride. Reduction of chlorine to hydrogen chloride. This is one of the reactions that you are studying in very lower classes, I think maybe in 7th or 6th class. So I hope you remember ammonia when it reacts with chlorine gas. Okay, so it is also a reduction reaction, but we won't go much about the reduction and oxidation that is taking place here. Now, what happens here? There are two products, N2 and HCl. So, suppose we have added very little amount of ammonia and large amount of chlorine, and if we are adding large amount of ammonia and less amount of chlorine, there will be two different kind of observation. Okay, so first we will discuss about excess amount of chlorine, less amount of ammonia. So if we are having excess amount of chlorine, there will be only one reaction, that is this NH3 plus 3HCl give N2 plus 6HCl. Okay, and the reaction, it will be stopping there. And there is one more thing. If little bit excess NH3 is present, NH3, it can also react with the HCl to form NH4Cl. So because of this, I hope you remember this reaction from HCl chapter. If NH3 and HCl, it is reacting to form ammonium chloride, you can see dense white fumes of ammonium chloride, that is from HCl chapter. Since the reaction is with ammonia or ammonium hydroxide, it is common for HCl as well as ammonia. Okay, now this is the case when we are using HCl and NH3, chlorine and NH3, where chlorine is in excess and ammonia is less in amount. Suppose we are taking excess amount of ammonia and less amount of chlorine. This is what that is going to happen. Sorry, this is the reaction when ammonia is excess, not chlorine in excess. If you are taking ammonia in excess, it will form N2 plus HCl, and the excess ammonia, it will react with all the HCl that is present, that is formed here. So it will react further to give ammonium chloride. So it will give the dense white film. So if you are taking excess amount of ammonia, it will produce ammonium chloride as the byproduct and N2 as the side product. Okay, so if you are taking excess amount of ammonia, less amount of chlorine, excess ammonia and less chlorine, the product is N2 and HCl. The HCl that is formed, it will react further with ammonia to produce ammonium chloride. Actually, this reaction is not that important. The reaction that you have studied before, that is the next reaction. I hope you remember this. NH3 plus Cl2. So here, instead of ammonia in excess, we are taking chlorine in excess. The product is NCl3 plus, what is remaining? Okay. NCl3 plus HCl. Okay, so I hope you remember this reaction. So you might have studied in the lower classes. When ammonia, when chlorine, it is dissolved in ammonia solution. There is formation of yellow explosive liquid. Okay, so this NCl3, that is called liquid nitrogen trichloride or nitrogen trichloride. It is a explosive liquid. It is yellow in color. So it is not explosive in the liquid state, but if you are letting that liquid dry on a surface, after that it can be converted into a explosive. When it is dried, it will form a explosive. It will be converted into an explosive. Okay, so even if you don't remember this reaction, there is a similar reaction that some of you have done in your 9th class. The reaction is this: NH3 plus, instead of chlorine, we are taking something else, that is I2, or in other words, iodine. So we are taking ammonia solution, to that we are dissolving I2 or iodine powder. So the product is Ni3 plus 3HCl. The reaction is HI3. Okay, the reaction is much similar to the previous one. And here, instead of yellow explosive liquid, you will get a purple explosive liquid. This reaction some of you have done in your 9th class. After forming this liquid, if you let it dry on a floor or something, after some time, if you step on that, it will cause some mild explosion. I think you can hear some crack sound as well as some sparks also. Okay, so if possible, you can do that if you are having the lab classes in the future. Okay, so this reaction, the first reaction, it is important. It was asked in the board exam last year. So don't forget to study about this reaction and also the color of the explosive form. And you are supposed to write that it is an explosive also. Don't forget. Okay, that's all about the reduction reaction of ammonia. The next one, it is the reaction with that of acid. Ammonia is a base. Now we are going to react ammonia with certain acid and we will see what is going to happen to ammonia. Okay, so reaction of ammonia with acid. Before going to that, we will discuss one more reaction, that is this. This reaction we have discussed today itself, but still, ammonia, when it is dissolved in water or when it is treated with water. I hope you remember that ammonia is highly soluble in water. So this is what that is going to happen when ammonia is dissolved in water. So I hope you remember the lone pair coming to the water and all that stuff. The product that we are supposed to get, that is NH4OH. So I hope you remember this one from the analytical chemistry chapter. So ammonium hydroxide, it is a weak base. Similarly, ammonia is also a weak base. So we are having two weak bases here. One is ammonia and other is ammonium hydroxide. We will discuss the reaction of ammonia as well as ammonium hydroxide with some of the acids. Okay, so the first one that I will discuss, that is the reaction of ammonia with, okay, let's say nitric acid. So we will compare the reaction of ammonia with nitric acid as well as ammonium hydroxide with nitric acid. So if you remember the previous case, so what will ammonia do? Ammonia is having lone pair, so it will abstract the hydrogen. So when ammonia get one more hydrogen, it will become NH4 plus cation, and whatever that is remaining, that is NO3. So it will form ammonium nitrate. So what happens if ammonium hydroxide is reacting instead of ammonia? So here it is already ammonium ion, so it is not having any lone pair, it is not having any free lone pair. The lone pair, it is already occupied with one extra hydrogen, so it is not having any lone pair to attack like the previous reaction. So it will be a simple crisscross reaction. So this is the cation and anion separation. So we are supposing to change the cation and anion. So NH4, it will get NO3 minus, and H, it will get the OH minus, or H plus, it will get OH minus. So we will get NH4 NO3 plus H2O. So if you are comparing both the reactions, so you remember what is NH4OH? NH3 plus H2O, you will get NH4OH. So NH3 reaction with HNO3, the reaction, it will yield NH4NO3. The difference when it is reacting with NH3 and NH4OH, it is just this. There will be an extra amount of water, that water is from the ammonium hydroxide that is being disturbed. So if you are comparing both the reaction, the product difference in with ammonia and ammonium hydroxide, that will be one H2O. That will be in the case of NH2OH, it won't be there for ammonia. So we will try some more reactions of ammonia and ammonium hydroxide. NH3 plus H2SO4. Okay, so as you remember, there is lone pair, it is supposed to extract hydrogen. The problem is there is no extractable hydrogen here. So what happens here is 2NH3, it will attack both the hydrogen to form NH4 SO4, and since 2NH4 is formed, it is NH4 twice SO4. Okay, so we will do one more reaction, that is with NH3 plus H3PO4. So here it needs 3, here there is 3 replaceable hydrogen, so we can take 3 NH3 to form NH4 twice PO4. Okay, so what this NH3, if we are treating NH3 with any of the acid, what NH3 do is, it will, the lone pair in the ammonia, it will take one hydrogen. So if there are 3 replaceable hydrogen, 3 ammonium molecule, it will react with the 3 replaceable hydrogen to form 3 ammonium molecule. Okay, sorry, 3 ammonium ions. So I hope you understood the reaction with ammonia and other acid. So I hope you understood this part. The next part, it is the reaction of ammonium hydroxide with metal salts. So here, okay, so the next is the reaction of ammonia. The next is reaction of ammonia with metal salts. So I hope you remember the reactions from the analytical chemistry chapter. So you were reacting 6 different type of metal cations with ammonium hydroxide as well as NaOH. So you are supposed to consider only those reactions with ammonium hydroxide here. So the reaction of calcium with ammonium hydroxide, there is no reaction. You can skip that part. Other than that, there are 5 other reactions. The first one, it is a reaction of copper with ammonium hydroxide. There are 2 steps. The first one, it will directly form copper hydroxide. So I hope you remember the reaction from the analytical chemistry chapter. You just refer that part. So copper with ammonium hydroxide, first it will form pale blue precipitate of copper hydroxide. Later it will form deep blue color with excess of ammonium hydroxide. So that is important. Fe, there are 2 type of Fe salts. One is Fe2 plus, it will form dark green color with ammonium hydroxide. The next one, it is Fe3 plus salt, it will form reddish brown color with ammonium hydroxide. So lead and zinc, both of them will form white color precipitate with little amount of ammonium hydroxide. In case of zinc, it will be white gelatinous precipitate, but if you are adding excess this white gelatinous precipitate, it is supposed to dissolve in excess amount of ammonium hydroxide. But if you are considering the case of lead, it will form a white precipitate. It is a normal white precipitate, but it is not so dissolving in excess amount of ammonium hydroxide. I hope you remember this much part from the analytical chemistry chapter. Nothing excess is added. So whatever that you have studied in analytical chemistry chapter about ammonium hydroxide, you are supposed to consider it here also, in this chapter also. Okay, now we are moving to the last part, that is test for distinguishing ammonia. Okay, so ammonia, if you are asking one of the teachers to identify the ammonia or to identify whether the gas or the solution, gas is ammonia or the solution is ammonium hydroxide, the first thing that we are doing, we'll just take it and smell it, because the smell of ammonia, it is that much easily distinguishable. There is no other chemical with this type of smell. Okay, so I hope you will be able to smell ammonia later in the future. So as I have told you in the beginning of this chapter, the ammonia, it is forming also, it is also forming in your toilets also from the decomposition of urea. So I think you have smelled a dilute amount of ammonia by yourself already, so you can smell it properly later. So ammonia, it can be easily recognized by its pungent smell. Now other than that, you can use some of the indicators to check the presence of ammonia. Suppose if you pass that gas or if you add the ammonium hydroxide solution into any of the indicators that we have discussed before, litmus, phenolphthalein or methyl orange, you get the color change. If there is a color change, there is a slight chance that it can be ammonia. It can be any other basic gases or basic solutions also. So it is not 100% sure that it is ammonia, but still there is a probability that it can be ammonia. Okay, so the most important test that we are doing for ammonia, it is the same test that we are, it is a similar test that we have already done to distinguish the presence of HCl gas. So the test is this. So we are having ammonia gas. If you are not having ammonia gas, if you are having some ammonia hydroxide solution or some of the ammonium salts, what we are supposed to do? We are supposed to heat it strongly. Either you can directly heat it if it is ammonium hydroxide or ammonia solution. If it is some ammonium salt, you can treat it with some of the alkalis. You remember the laboratory preparation of ammonia, right? So we are taking an ammonium salt, we are adding it with one of the alkali, strong alkalis like calcium hydroxide or KOH or NaOH. After that, we are supposed to heat it strongly. You will get ammonia gas. So that ammonia gas, if you are taking that ammonia gas and just take one glass rod, a single glass rod, dip that in the dilute hydrochloric acid. So we are having ammonia gas in a gas jar or something. So we are taking a glass rod that is dipped in dilute hydrochloric acid. When it is brought near, the ammonia gas, so you can see or you can observe a dense white fuse that is due to the formation of NH4Cl. I hope you remember this from the last chapter. The only difference is instead of ammonium hydroxide, we are using ammonia. The test was this same reaction was there for the test to detect the presence of HCl. Okay. Now there are some other tests. Ammonia, if it is passed through copper sulfate solution, the blue precipitate. Okay. The same test as what we have, this same test that we have discussed in the analytical chemistry chapter for copper. So if you are taking copper salt, if you are adding excess little bit of ammonia or ammonium hydroxide in that, it will give a pale blue precipitate. If you are adding excess of ammonia, it will turn into deep blue solution. So this is a test that is specially for copper and ammonia. So deep blue coloration, it will be only when we are adding ammonium hydroxide. So if you are having ammonia gas, what you are supposed to do, take a copper salt solution. You can take copper chloride, copper sulfate or any other copper salt solution. Pass a huge amount of ammonia gas into that solution. First it will form some pale blue precipitate, after that it will form deep blue coloration. If there is a deep blue coloration, you can confirm that it is 100% sure that the gas that we are adding or the solution that we are adding, it contains ammonia. Now other than that, then there is one important indicator for the ammonia, that is called Nusselt's reagent. Okay, the formula is K2HgI2. I'll write it here, K2HgI2. This formula is important. I have seen this formula. I have seen in many question paper that they have asked this formula. So just by heart that the name of the solution, it is Nusselt's reagent. So if you are adding any of the ammonium salt, or if you are passing the ammonia gas to the Nusselt's reagent, it will turn into a little bit brown color solution. Or you can do this same test by a different method, that is dip the Nusselt's reagent in a filter paper or a piece of paper, let it dry. After that, let the paper, bring the paper nearby the ammonia gas or ammonia solution, it will turn into brown color. So this is the test to identify ammonia gas. Other than that, there are some uses for ammonia. So one important use that I can tell, that is ammonia is one of the important chemical that is used to manufacture many of the ammonia salt as well as nitric acid. It is one of the important reactant for the production of nitric acid. So there is one more part, that is this ammonia is used to produce a lot of fertilizers. I think you have studied about NPK fertilizers in biology. NPK, nitrogen, potassium, calcium fertilizers, as well as urea also. So just as I told before, urea, it is one of the important constituent in the urine. So urea, when it is decomposed, you get ammonia. So in other words, ammonia, it is used to manufacture urea industrially. So urea, it is one of the important fertilizers. It is normally manufactured from ammonia. Okay. So other than that, there is a part in your textbook telling that about ammonia is one of the important refrigerant. It is one of the most eco-friendly refrigerant. You can write all about that, but in my opinion, whatever that is written in this part, it is little bit wrong. So the reason is, I think this much topic from the syllabus, it is little bit outdated, because no one is using ammonia as refrigerant. There are many disadvantages. One important disadvantages is this: there are many better gas that we can use instead of ammonia. So there is some advantages of using ammonia also. Ammonia is a gas that doesn't cause ozone depletion, but there are many other gas that doesn't cause ozone depletion and that are better than ammonia. So we are using gases like freons as refrigerant. They are not ozone depleting and they are not dangerous. They are better than ammonia. Therefore, we are normally using some other freons. Okay, and there is one important thing, that ammonia, it will easily react with copper. So I hope you remember what is behind the fridge. It is a large array of copper tubes. So the gas or the refrigerant, it is supposed to pass through the copper tubes. If ammonia is reacting with that copper tube, it won't be good. So, and other than that, some other advantages of using ammonia that is mentioned in the textbook, that is this: you can easily identify if there is any leakage in the refrigerant gas. If there is any leakage in the refrigerant gas, there is nothing that you are able to do. You can also understand after that fridge is not working. So many of the points that is written in the textbook, it is not relevant and it is not important. So ammonia is a gas that can be used as a refrigerant instead of CFC, but there are many other gases. Ammonia can be one of the options. That is what I can tell. Other than that, you can write the uses like for the manufacture of many chemicals, fertilizers, acids like nitric acid, nitrous acid, etc. Okay, so that is all about this chapter. This was the second part under the chapter study of compounds. So in your syllabus, in your first semester syllabus, there are this much chapter. The first chapter, that is periodic table. The second chapter, chemical bonding. Third chapter, it is not there. Fourth chapter, that is analytical chemistry. Fifth chapter, it is not there. Fifth, sixth, and seventh we are skipping. We are we will take that for the next semester. So the upcoming chapter, that is study of compounds. In the study of compounds, only two parts is there for the syllabus under the first semester. So periodic table, chemical bonding, analytical chemistry, study of compounds under the study of compound, HCl and NH3. These 5 chapters, it is there in your syllabus for the first semester, and we have completed these 5 chapters. I hope you study at your home. You prepare well for your first semester examination. Okay, that's all for today. Thank you.